Right, the recording has started, that's good. Okay, so we can start the session. As I say, welcome to the End2End Sustainability Technology Challenge session. My name's Vicky Summers. I'm a Principal Research Engineer with the Sustainability team at the National Composite Centre. I've worked with the team since last November, and before that I was in automotive R&D, where I gained experience working in sustainability, circular economy, and materials mainly. My background is polymer materials, along with some surface analysis and adhesion. Since starting with the NCC, most of my work has been around consideration for end of life. So what I'm going to suggest is that I share my screen so that we can just see the structure for the next hour or so. Okay, so hopefully I'm going to be sharing my screen, and hopefully you can see that. If one of the panel can tell me if you can see that, that would be great.
Yes.
Yeah. Okay, that's great. So what I wanted to do next is to ask the panel if they would introduce themselves. Perhaps as we see them here, perhaps we'll start with Dave from Collins Aerospace.
Yeah, hi Vicky. Hi everyone. So my name's Dave McConnell. As you see, I'm the Associate Director for Advanced Materials at Collins Aerospace Interiors business unit. I've been with the company now about 10 years. Always working in interior business units and seating and galleys and across advanced technology. So interiors is one of a little bit about interiors. We're one of 6 strategic business units of Collins Aerospace, and we supply products and solutions right across cabin and seating, both commercial, specialty, executive seating, structures and monuments, galleries, lavatories, and all kinds of water solutions, and then all kind of other kind of belly inserts, lighting, oxygen, PSU, and even the evacuation systems. So I currently lead the Advanced Materials Group. I'm based currently in at the Interiors headquarters in Winston-Salem, North Carolina. But my group and we support all the interiors business units globally in materials research and new technology areas, particularly in areas such as polymers, plastics, composites, fabrics and textiles. And more recently, my group led the initiative for cabin hygiene and material solutions in the cabin with the post-COVID situation. One of my core teams is based in Northern Ireland, and is really one of our composite centres of excellence, working in composites research, engineering and manufacturing, including projects on sustainable materials and bioresins, thermoplastics and recycled materials. So really interested on the discussion we're going to have over the next month, as well as any future engagements or collaborations going forward.
That's great, thank you. Magda from EasyJet, would you like to go next?
Yes, thank you. So hello everyone, my name is Magdalena. I work for EasyJet as Sustainability Manager. I only joined EasyJet in March, so I had a bit of weird start being furloughed from April to August, but I'm glad to be back and picking up on sustainability agenda. My background is really environmental management, sustainability, various aspects, waste management, energy efficiency. I worked in various sectors, and about 6 years ago I started a role with Thomson Airways at that point. So I've worked in aviation sustainability for about 6 years now, both on airport sites as well as the airlines. In terms of, I don't have to introduce who EasyJet are. You're all pretty much aware. But just to say a few words in terms of our sustainability journey. Last year, we launched our sustainability strategy, which is based on 3 main pillars. First one is very much about tackling carbon emissions, so operating efficiently, introduction of new aircraft. Stimulating carbon innovations, some of our partnership with Airbus and Wright Electric on new technologies, so including hybrids and hydrogen aircraft. And the third pillar is going beyond carbon, so it's looking at single-use plastics, waste management, sustainability in procurement, and just wider sustainability piece around destinations. And so I guess how it aligns with the panel, I work mostly in the going beyond carbon pillar of our strategy, and which is why I'm today one of your panelists.
That's great. Thank you very much. Samantha from C-Sense, would you like to go next?
Yes, hello. Good to see everyone here. I'm Samantha Bunyan. I'm co-founder and head of industry engagement and also the sustainability ambassador for C-Sense. C-Sense, for anyone who doesn't know, was founded in 2014, and we specialize in lightweight, rapid process, sustainable composites. We're both manufacturers and developers, and we've been doing a lot of work over the last 3 years now, really looking at recycled carbon, at bioresins. Our flagship product, if you like, is a very lightweight seat back that is made out of a matrix of virgin carbon fiber and a REACH compliant phenolic resin system, and we're working on at the moment on recycled carbon iterations of that idea and that philosophy. And I'd be very keen to talk to everyone here later after this, but especially Magda about her approach at EasyJet. There's huge things that will hopefully come up in this conversation about embodied carbon, about transportation, not simply about the materials that we're using, which all play actually often a much larger factor in whether or not something is actually sustainable at the end of the day.
Thank you. And Nigel from SWS Certification.
Thanks, Vicky. Good afternoon, everybody. Good to see some faces. My name is Nigel Smith. I'm Managing Director and Head of Design of SWS Certification Services. My background is over 30 years in the aerospace, defence and civil aviation market, primarily in development, research, development, trials and certification. Just over 16 years ago, myself and my business partner, we set up SWS certification to focus and specialize on, the task of certifying right across the board. We are an EASA and a UK CAA Part 21 design organisation, and we have within our portfolio and focus largely on cabin interiors for small and large fixed-wing aircraft and a full range of rotorcraft as well. We have a particular specialisation with certifying seating products, especially unique seating products. Just give an example, Air New Zealand Sky Couch, and another, and currently we're supporting the Williams Advanced Engineering Airtec project on the certification side. Now, obviously, our emphasis is on certification, but we interface with a lot of aspects across the aircraft interiors, and sustainability is also one of them. Sustainability, as far as we're concerned, applies right across the entire process of getting new product and technologies into the aircraft. Certification also, in some form, applies to the whole process. Not, as we experience quite often, we're introduced, in our opinion, too late into the program, as either halfway through or partway through a design or at the end of the design, and then we're ever chasing the means of getting things approved. So, as far as we're concerned, to develop sustainability effectively, we must also develop the CERT process and improve the CERT process. And that includes the regulatory requirements as well. And this must be done in parallel with any product or project that's being developed. We can't allow certification to stifle innovation, but to support and enhance the process of getting a safe, sustainable product and technologies on board and flying. And I look forward to the next hour.
Oh, that's great. Thank you very much, everyone. So just to give a little bit of background for today's event, is to think about the strategic insight for UK aircraft interior supply chain investments, particularly investments in technology for the future, to promote and develop the technology challenges to lead those investments, and ultimately for ATI grant funded projects, and to draw out the technologies. So for today, we need to be thinking about the challenges that are ambitious, tangible, relevant. Are they important for future UK competitiveness and long-term value? What the technology challenges actually are, and can they be quantified? What the KPIs are, and what the underpinning technology might be. And I know that the previous work has generated the 4 challenge statements that are here, that I hope that we'll be able to cover all 4 challenges in the next hour or so. So we're looking at how to improve cabin energy efficiency by 75% for the next generation of cabins. Looking at 100% recyclable, bio-derived and durable cabin products. The 3rd challenge statement is to develop the use of recycled materials for new products by 2025. And looking at the final statement, by 2025, to reduce the time from lab to market for new sustainable technology and materials by 50%. One of the things that I would like everyone to think about while we're in the discussion is how to complete the mural whiteboard, and I've put a link in the chat. So if you get any ideas while we're talking, if you would like to add a Post-it note or many Post-it notes to the mural whiteboard, if you could put your company name so that we can identify who's posted the comment on your Post-it, so you can add the capability that's current, and then also to add future technology opportunities. And these whiteboards will be open for a week, and if everyone can populate the whiteboard, and we can look at those Post-it notes to try and identify collaborative projects, consortia to work together on future projects in sustainability in the coming months and years. And also, if you have a question for this session, if you can submit your questions to the Slido website, and again, I've put the necessary website in the chat, and if you can do that, then I will ask the questions of the panel. So if we can start with the first challenge statement, which is to improve cabin energy efficiency by 75% for the next generation of cabins. I will stop sharing my screen. Okay, and what I'm, okay, I just need to get back to where I was. That's it. And so I'd like to ask the panel, perhaps we'd start with, I'm just having a little bit of trouble with my screen. Perhaps I'd like to start with Magda from EasyJet, if you'd like to talk about cabin energy efficiency, how it might affect your organisation and where you'd like to be positioned in the future.
Okay, thank you. So yeah, important statement for us. Carbon efficiency is is one of our key material issues. We've done actually last year we've done for the first time an exercise to look at our total emissions, not only just from flying the fuel. Fuel is obviously our biggest area for carbon emissions. However, we also started to look at our supply chain and scope 3 emissions. So scope 3 emissions, if you look at the scope 1, scope 2 and scope 3 of total emissions for EasyJets, scope 3 is about 20%. So those are the areas definitely that we also need to start looking to improve. Things on fuel efficiency, flying efficiency is pretty much embedded into the business already. Many procedures and flying more efficient aircraft in terms of the new aircraft implementation, albeit a bit delayed. Well, now with COVID situation, we had to readjust some of the fleet entering into service. So on the cabin efficiency is certainly something that very, very, very important.
Thank you. Nigel, would you like to comment from a certification point of view?
Certainly. We are seeing quite an increase in cabin interiors, specifically around weight-saving exercises, and also electrical systems within the aircraft, because if you can reduce the amount of electrical energy that a system requires from the aircraft, that reduces the amount, obviously, that the aircraft has to provide and work. So that also has potentially an impact on fuel. The other thing certainly with lighting systems, they're very light, they're very reliable, but certainly those that we're approving now, and very, very efficient. With the weight saving side of things, it's a challenge for design because it's introducing, in some cases, completely new design concepts, and Airtec is a classic example where there's a lot of space, so there's reduced primary structure. That primary structure has obviously got to meet all the regulatory requirements. It introduces new materials, and those materials have to be qualified, and then they again have to meet various regulatory requirements, typically structural, to get the structural data and flammability. And especially when you get into large panels, you can land up with a very good, efficient core structure, but it's then the finish that goes on that creates the problems. So again, we're starting to see areas where part count is being reduced, surface finishes are being more integrated, but also trying to improve maintainability and reliability, so that basically increasing the life cycle of a product, but also trying to build in some means of efficient and effective repair if that is required.
Thank you. Samantha, would you like to comment?
Yes, so as manufacturers of lightweight components, with a particular focus on a large structural area, the seat back itself, We've always been very clear that we know the criteria we have to meet, all of the things that you've just spoken about flammability, fire, smoke and tox, structural integrity. And we've known that right from the get-go that whatever materials we develop or are involved with developing need to meet those requirements, and also have a finish that is as near perfect as A-class finish as we can get. One of the ways in which we also save or reduce our carbon footprint is by using very energy efficient processing methods. So we tend to press rather than autoclave our parts. We don't like to throw loads of vacuum bag equipment into a bin, so we're not contributing to landfill. But one of the main problems that we have to resolve, and which is why we're looking a lot at natural fibres now, is that obviously a large amount of our supply in carbon fibre comes from a long way away. So the carbon footprint that's created simply by transporting that to us before we even start to work with it is an issue. And another issue that we might touch upon later is that bioresins are definitely the buzzword, and are definitely something that we're working a lot with, and looking at how we might replace some of the phenolic systems that we're working with bioresins. But again, when you look into the detail, you see that a lot of the products are derived from sugar waste, which is imported from places such as the Dominican Republic. And so that again makes it difficult to genuinely say that this is an improvement.
That's great, thanks. Dave, last but not least.
Yeah, so on the question on carbon energy efficiency in particular, I guess Collins is ideally placed here because we have many different carbon products, right across interiors. So when you think of, the carbon efficiency, you think of, the interaction between galleys and galley inserts, both electrical power, thermal efficiency from refrigeration, the integration between lavatories and water solutions, how do we reduce the water usage, think of the lighting systems that were just mentioned in the galley inserts, so smart controls and sensors, so using lights when they're needed and switching off and on, or they need at a high level or bright level. And then I guess just the general weight saving at an aircraft level. As mentioned that that helps the aircraft and the airlines and the operators safe and it's fuel efficient. So optimization of the products to design efficiency, process and materials to really optimize the weight at an affordable cost point. So seats, galleys, lavatories and all that integrated. So I think the key here is we take it as a one Collins approach. So we have both interior and then we've got carbon management systems. So I think we're looking at it holistically and a systems approach to try and hit that KPI and create an overall energy efficiency across the cabin.
That's great, thank you. And the second challenge statement, and perhaps the third one, maybe we could tackle it together, are regarding 100% recyclable, bio-derived and durable cabin products, and developing the use of recycled materials for new products by 2025. And one of the questions that has come up in the Slido website is to talk about the difference between sustainable materials and recycled materials, and perhaps we could think about that in conjunction with another question that's come up, which is, which I'll read out. When the 787 and the A350 begin to come out of service, which have up to 50% composites, including carbon and epoxy, will this pose a challenge for plane recyclers? So perhaps we could go around again and begin with Magda from EasyJet.
Mm-hmm. In terms of, so would you like me to start in terms of commenting, or are we trying to answer the question? Sorry.
If you could talk about recyclable, bio-derived products, durability, and how we might develop that, and we can we can discuss that for the next 10 or 15
yeah.
minutes or so.
Yeah, so all together, makes sense to talk about everything together. Definitely, again, durable cabin products are very important in terms of recyclability, and difference between the sustainability of the products and recycled products. Obviously, recycled products suggest where we're taking our primary material, so we're trying to put something back. Sustainability has a wider remit, wider meaning than just where the material for a product is coming from. So the two should not be used interchangeably. In terms of challenge for planes coming out of service is a very good question. I am aware that Boeing, one of the eco-demonstrator programs, they were looking at how to break the aircraft and recycle, reuse as much as possible. However, it was the 757 Boeing that they managed to reuse and recycle up to 90%. So definitely the challenge with the like 78 and 350s. The use of recycled materials for new products, and that is the one I'm quite interested as well, because it's something that coming up in our discussions, internal discussions as well.
And how do you say that would affect the passenger experience, perhaps?
In terms of passenger experience, sometimes I see that there's this perceived passenger experience. I think that there's a lot of movement now in terms of expectations from passengers. Sometimes we think that passengers might want it, but we're not checking it, we're not asking. So I would always challenge, when we say, oh, customers would not want this. It's definitely, a lot of, over the last maybe 12 months, with even before the pandemic, the customers' perspective shifted really a lot.
Yes. And Nigel, what would you say would impact is the impact on your organisation or for your organisation when we're looking at end of life versus the through life sustainability, thinking about bio-derived and recycled materials?
Yeah, bio-derived. We were involved some years back with working with an organisation who were developing composite panels, which had conventional resins but was using hemp. And the two big areas that we came up against, the resin was easily controlled and we could get it to meet various requirements. The trouble with anything that's bio is that there's an element of variability in it, and that was the biggest problem. And it literally, on occasions, it came down to where the hemp was being grown, what the season was like, and everything else. So even though it may look the same and they can create the fibre and everything else, when we put it with the resin, we then found for some reason or other it structurally was not up to it, or flammability was failing. Sorry, and this was especially in the large panel area where we were getting smoke and heat release. So there was huge variability. When it came to recycling, yes, that was quite a bit easier, but again, it depended on the resin, because if you're using thermosets, they're readily more recyclable than thermosets. thermoplastics and thermosets, yeah. And again, one of the big issues with any recycling materials is the end product. With metallic materials, they're much easier to control because you know the specification of the material. So if you've got an aluminium of a particular specification and you melt it down and put it through the normal process, you'll get the same material, providing it goes through all the same treatments. With a recycled composite material, you can actually land up with something different at the end. So you could actually be in a situation where you've almost created a new material or a new process to be able to use that material, and then you've got to certify it again. Now, if the recycling is considered within the design and the whole, as you say, life cycle of whatever's being developed, then you can potentially look at the byproduct that you've recycled, how that can then be used, and it doesn't have to come back into aviation. It can go out somewhere else and be used. And as far as developing the use of recycled materials for new products by 2025, well, you know, products and materials are being recycled now, and it's really the good question about the 787s and the A350s is, how do you recycle those materials? As I say, if they're, you know, depending on the type of composite they are, you know, they can do all sorts of things, crush it up, shred it, and, or maybe you reuse the parts. But again, with non-metallics and the composites, those aircraft could have been in storage for years. So you've then got to be in a position to assess the airworthiness of that composite component. Again, with metallics, it's a lot easier to control. So I think the short answer for me is, you know, recycling composite aircraft, I think, is going to be a big challenge, either through reuse of components or doing something with the materials so that you can use those in another process. Trying to get 100% recyclable. Certainly you can pretty much do that with metallics. How feasible that's going to be with bio-derived, because it all depends. Anything to do with composite is largely going to have a synthetic resin or something like that to be able to bring it all together. And then, as I say, once you've developed that, it's got to meet all the requirements. And the important thing is the continued airworthiness of that product. We know that composites are affected by all sorts of things, UV light, and especially with COVID as it is now, where, you know, there's technologies to use UV light to sanitize products, and we're actually involved with something with that at the moment. And then, you know, there's the sanitizing agents, etc., etc. So hopefully that gives some insight as to the things that we're seeing and having to consider with recycling and sustainability. And if I may, I think my interpretation of another question there about difference between sustainable materials and recycled materials, I've always considered that recycling is just part of the sustainability process, because material sustainability starts right back from where you source it from, how you process it, how you use it in your design and manufacture. So recycling is the end part of sustainability. So hopefully that helps.
Thank you, that's great. Samantha, can I ask you what you think the opportunities are in materials design processing for recycled materials and bio-derived materials?
Yeah, I mean, I think they're huge. I totally hear what Nigel's saying about metallics. We know what their properties are, and they're tried and tested. but I guess the same could have been said about the first ever glass fiber and plastic products that when they came out, and they've been more or less accepted. We've got a big problem with recyclability of composites, and I'm part of the Rediscover group that, Vicky, I know you're one of the chairs of that, through the NCC. And I agree with what Magda was saying about having to look at sustainability and recyclability, albeit that they're connected. You have to kind of view them separately. We've got big issues, not only with aircraft needing to be recycled, made out of carbon fiber and epoxy resin systems, but also there's a lot of talk, a lot of chatter about wind blades at the moment, and horrific pictures of great areas of land with bulldozers ploughing these wind blades into the soil, because nobody knows how to disassemble them, how to deconstruct them. I know that ELG Carbon Fiber are doing a lot of excellent work recycling carbon fiber. They use a pyrolysis process, which is pretty energy intensive, but is still, I believe, from looking at the basic data that I've looked at, that it's probably still a more efficient process than a fluidized bed system. And one of the reasons that we're keen to work with recycled carbon fiber is, we've had some very impressive results from development work we've done with it to replace virgin carbon. Not all virgin carbon, but I think one of the things to think about is also the performance criteria of these products. Not everything needs to be as tough as you're going to get out of an epoxy resin and a virgin carbon tow. And so there is movement and flexibility to look at different components or different areas of those components, and look at combining some of those products that might have a greater variability with your ingredients that don't have that level of movement or fluctuation. And yes, I was speaking at an event yesterday where we were talking about flax. Nigel and Nick from SHD Composites was talking about how flax grown on a north-facing chalky soil may be very different from flax grown on an east-facing clay soil, and how do you control that? And I think this brings us back to the whole sustainability picture, which is that unless we are clear, and how apt that this webinar is called End2End Sustainability, unless we're clear about where we're getting the components from in the first place and where they're going to end up, and what the actual larger sustainable picture is, what does affordability actually mean? It no longer simply means getting the best price to the supplier, but it's about bigger things than that. It's about how we look after our planet. Without sounding too hippy-dippy about this, that is what we're all trying to do.
That's great, thank you. And Dave, do you think there are opportunities in your area for bio-derived and recycled materials?
I think there are opportunities, and I think it goes back to what Samantha said and what Nigel it depends on the application, right? If you look across the cabin, there's different applications and different needs, different specification requirements. You can look at it from a structural point of view. You've highly, what we call interior primary structures, seat frames, things like that, which have a high quality needs, safety requirements, so a very tight spec. But then you have, shrouds and lightly loaded panels and other, armrests maybe on a seat that are more about abuse loads, but they're not safety critical. So I think we need to look at the application from a structural point of view, and also Nigel touched on the flammability, and high requirements are the OSU and the smoke density, where a little change in material has a big impact on the end result in that test. So that might be a challenge for some of these materials, but there's other applications that we don't need to meet. More structural requirements are not exposed. They don't need to meet those requirements. It might just be a vertical burn. So I think it really has to focus on the application and where the opportunities are from the material type, the process for that application. Of course, including cost, economics, and Samantha mentioned affordability, but it's not affordability on the material, but what's the cradle to grave affordability, the full life cycle consideration.
Thank you. Right, so we've been given a 10-minute warning, so perhaps we need to move on and talk about the fourth challenge statement, which is by 2025 to reduce the time from lab to market for new sustainable technology and materials by 50%. And Again, if we go around, and I'll ask Magda first, I can only assume that this would be a very positive thing for your organisation, organisations like yours, to reduce the time to market for these materials and technologies.
Yes, definitely, and it's really throughout entire aviation kind of supply chain, not only on cabin interiors. It just takes so much time from the concept to certification. It's the same discussion with sustainable aviation fuels, for example. It just takes an enormous amount of time, effort, tests, which, if it could be sped up by 50%, it would be amazing, because that would definitely help to introduce the new technologies, the new materials more quickly. So definitely something that we would definitely welcome. Whether it's feasible by 2025, I guess that's a discussion really for the panel.
Thank you, Nigel. So, is it feasible, and what are the opportunities?
Potentially, it's feasible in certain areas, like Dave said. It's a lot of it's going to determine where its application is. Coming back to the biomaterials, you could probably create something quite quickly, get it certified to be used for carpets and curtains, but that material probably couldn't be used as a cover on seating, for instance. As far as I'm concerned, one of the real important things with any development, whether it's design or materials or anything, is that certification has to be brought in right at the very beginning, because the first thing that you obviously identify is what are the current requirements, and what is it that you're trying to achieve with this product or material or technology. And then the whole point of certification is that whatever is developed and goes on the aircraft is safe. It's a simple statement, but it's so hard to achieve. And it's working through in parallel with what you're trying to develop with the existing certification requirements, but then trying to develop, whether it's through rationale, whether it's through certification development, but alternative means of being able to certify and demonstrate that it's safe. To give you an example, anybody involved with seat cushions, there's various foams, there's fire blockers, there's Velcro, there's dress covers. What it takes to manufacture test articles and all the testing that has to go on, because not only do we do what's called the oil burn or kerosene burn test, which is basically just make up a representative cushion, which is actually generally bigger than the actual seat cushion, so you can't use the seat cushion. So you have to manufacture a dedicated test sample or test samples. You then burn that and it all passes, that's great. But you've then got to go through the vertical burn scenario with all the individual materials. And if you change any of those, you have to go through all of that again, potentially. So we've got to start looking at those rules and regs, those means of being able to demonstrate compliance and to make sure it's safe. And to be fair, the regulators are trying. A good example is repairs. A galley or a lavatory or something like that, it's all scuffed up. They need to repair the dents and they want to repaint it or resurface it. And that's a big challenge when you're coming to have to recertify, because we can focus on the actual materials and the repair process that's going on. We may not know what the actual base material is that we're putting it on. Now, we've had a little bit of involvement with it. Is basically the EASA have come up with this critical panel process where you have particular known panels which are on the borderline of passing or failing, and then if you put your repair or your new material on it and it still passes, then that's acceptable. So that's the sort of area that we've got to go into, is developing alternative means of demonstrating compliance, and even looking at some of the the compliance requirements as to are they out of date with how aircraft are now. There's a lot more coming in with composite aircraft, more composites into seats and everything else. And what we see quite a lot is that it's an aircraft level requirement, like damage tolerance. They then bring that into seating, and all of a sudden you're into a huge certification challenge to demonstrate what level of damage that structure can sustain before it becomes non-airworthy, or before it becomes non-airworthy. So to sort of try and wrap this up, for me, the key thing is to get, to improve getting the time for getting from lab to market, is that we've got to look at ways of improving the certification process, and in parallel, what can be done to either update or develop or find alternative means of demonstrating compliance.
Thank you. Samantha, have you, what's your opinion about speed to market, commercial and market factors, new technologies, regulations?
Yeah, I agree wholeheartedly with what Nigel said, that we need to understand the criteria that's necessary for compliance early on. It's often quite a costly exercise, but I would say that if you don't do it, then there's far greater cost likely down the road. Martin Derbyshire of Tangerine was speaking as part of the conference earlier, and I almost fell off my chair when he said it had taken 16 months from concept drawing to getting the seat on the plane for British Airways, the yin yang backwards forwards facing seat, and you could see the frustration in Martin, and in the knowledge that that's just a pipe dream now, to think that you could have that kind of fast track process. So in order to reach the date that the question's asking for, it's going to be tough. But unless we all, I think one of the ways forward is for us to genuinely collaborate as much as possible. And one of the things that the ATI facilitate is a number of funded programs that mean that is more possible, and it is possible for an innovator, an SME such as C-Sense to work with the likes of Collins, and to work with Nigel, and to work with the test houses really early on, so that we can start to develop those new materials and develop those products and get them tested and get them certified and get them on a plane. Yes, it is possible, but I think that time is a major factor.
Thank you. Dave, do you think there are opportunities with simulation, digital transformation? What are your thoughts on speeding up the time to market?
Yeah, and I'll touch on that. I just want to touch on what Samantha just said. Is industry collaboration. I think industry collaboration is a big thing. I mean, internally we create a lot of processes called IPTs, integrated project teams, where we have different functions. We don't seem to do that as well as an industry. A lot of businesses do it internally. We don't seem to do it as well as externally. So this is, a perfect example here of a collaboration: material supplier, product supplier, certification body, and end user operator. Right? We all have a needs. We all come up from a different way. If we, focus on, what our needs are, what the requirements are, I think that's one. Industry collaboration is a big thing. In terms of digital and virtual and CA tools, I think that's one thing. Yeah, will definitely help the industry. Whether it's through material model analysis and understanding, and Nigel talked about, all the different certification process you have to go through. You have to do an oil burn, you have to do a vertical burn. Sometimes you have to do a smoke and tox and an OSU test. It's all about, at the end of the day, it's all about risk reduction. But a lot of the regulations, the way the regulations are written, they don't allow to kind of bend the rules, if you like. Right? It's a very methodical process, and I think as an industry, we probably need to take a step back. What is it we're really trying to achieve with a lot of these certification methods? Are we trying to reduce risk, or are we just trying to create paperwork for the sake of paperwork? So I think certification, going back to what Nigel said, and material modeling, taking that building block approach, the pyramid, if we can really understand the materials at a component level, a subcomponent level, we can then reduce the testing rate and the speed at a end product level, so we don't have to do the full scale expensive tests. So I think there definitely is an advantage to taking that more virtual approach in the way forward.
Oh, that's great. Thank you very much. I think because we've run out of time, I think we'll leave it there. So I'd very much like to thank the panel for their participation, and I'd like to thank everyone who's listening for joining. I'm really sorry if I didn't get round to asking your question to the panel, but hopefully you'll be able to think about the discussion that we've had and complete the mural whiteboard. I really invite you to take a look. Hopefully it'll be quite straightforward to complete, and then we can look at that whiteboard afterwards and hopefully build some collaborative projects as we've just been talking about. So yes, I invite you to join the next session that I'm sure you've had your invitations, and I'd like to thank the panel again. Thank you very much, everyone. Thank you for joining the discussion. Thank you.
Thanks.
Thanks for listening.